Hello everyone, in this video we will mainly discuss how can we create one TwinCAT 3 project for motion control and how can we set up the hardware configuration and motion access setting. I will go through the motion access setting in this video. After we install the TwinCAT 3 software, we will see the TwinCAT XAE. We can right-click, click the Run as an administrator. Let's set up one project first. Okay, at here, make sure you are selecting the TwinCAT projects. Okay, select this XAE project and select the location and select the project name. Keep in mind, now we are doing the project, so this is your project name, TwinCAT MC sample. I will name this. Okay, click OK. Okay, now we set up the project, and next, let's set up one PLC project. Okay, click this Add a new item. And here, let's select this standard PLC project. And make sure, by default, your PLC project will be created under this your project directory, which is correct. So just to have a glance, make sure that is under the project directory. Because sometimes if you create a PLC, that PLC project actually is a standalone. Sometimes when you create one PLC, maybe accidentally you select another directory. That would cause your PLC project not the same directory as your project. So it will be very annoying because sometimes when you archive your project, maybe that will only archive your project, this shell, but your core of the program, your PLC project won't be archived because your project and the PLC, they are not in the same directory. So keep in mind, make sure your PLC project is under your project directory. Okay, here, the name, this is the PLC project name. You can see now it named Untitled. Okay, so let's name that MC Motion Control. Now, this PLC project, this is the one empty PLC project. Under this POU, that is the main. So this is our code, this area. But for the I/O and terminal hardware configuration, they are under this I/O, this area. This is a typical Beckhoff TwinCAT style. Their I/O and the PLC code, they are separate. This allows the system can be configured very flexible. But if you come from Siemens or Allen Bradley or Omron, that is a little bit confused. In the TwinCAT project, the PLC, the code is code, but I/O is I/O, so they are separated. Okay, here, under the I/O from this device, I will assume we are using the CX2000, for example, CX2030. Okay, so right-click, click this Add a new item. So for this CX2000 series, basically we are using the UserCAD, this style. So firstly, I will select this UserCAD master. From here, right-click, let's add the terminals. So firstly, let's add this power supply module, EK1200. Click OK. Under this, so right-click, let's add other terminals. For example, for the digital input, we can select this, EL1008. This is the 8 inputs digital input. And for the digital output, we can select digital output terminals. For example, the common used EL2008, 8-channel digital output. Okay, they are just an example. So next things, let's configure that EL7200. So let's scroll down and find out this drive and the access terminals. We will see EL7000. For example, let's select this EL7201. So this is servo motor. Okay, let's select. And when we select, it will pop up, apply link, access to NC. Make sure CNC means we will develop the one CNC system. So, but most of the cases we will use the TwinCAT PLC running as a motion controller only. So we are not developing one CNC machine. So we will select this NC configuration. When we click the OK, so we will see here the system will automatically create this motion, this folder. Because to set up the motion control, we will set up the access under this motion. I will introduce this after. Okay, we set up this motion terminal Other than this, we can add 2 analog cards. One is analog input. For example, the typical used EL3042, 2 channels input card, analog. Okay, right click, let's add analog output. For example, we will select this EL4012, this 2 channel analog card. The reason why I set up the analog input and output cards, that because sometimes for a simple motion loop, we could use the analog output to control one servo motor or DC motor, and use the encoder or the analog input running as the feedback, that positioning feedback. So we can implement the positioning control loop using the analog output and the analog input. So let's click this analog output. So this is common used terminals or cards from the Beckhoff. Also, in some cases, if you try to connect one AX5000, the drive, probably you could use this card. Right click, click this add a new item, and we can go to the system terminals and select this EK1122. That is a 2-port Ethernet junction. Click OK. So under this junction, it allows us to, from this module, to connect other UserCAD devices, for example, the drive system or remote I/O or the wire bank. Okay, this is the typical procedure to configure the I/O hardware configuration for the Beckhoff control system. Okay, to configure the access play a very important role, running as a bridge, connect your code, the motion control code, and the motion control hardware. So we will create the access here, expand this motion, and from this access here, let's right click, click add a new item. And now it's true that because when we set up this EL7201, that time I clicked that the NC selection, so it automatically create this access 1 here. If we double click, that is access 1 already. And keep in mind, now that type is a continuous access. If we go to this setting here, we will see, because we used this terminal 4 here, it automatically connected this I/O here already. And this link to PLC, that means once we create the logic access, once we click this link to PLC, we will see that variable, the variable is based on the access variable. We haven't set up yet, so that's why now it shows the empty. But here, because we are using the terminal 4, that's EL7201, so the system automatically connect here. We can click this none, so it will clear. By default, it should be like this when we create a new access. So now the system automatically connects to terminal 4. Okay, no problem. And under this access type, so we can select. So as we can see, there are so many drive type we can select. It's based on the actual hardware we are going to use. And because this EL72, this terminal hardware, that is connecting one servo motor, so it's receiving the encoder. So if we go to the encoder portion, go to the NC encoder, so we will see that automatically connect to that module. And here, it also automatically connect to the encoder can open that feedback. So from this job list, we can see there are so many encoder type we can use. This access system automatically created. So let's manually create a second one. So right click, click this a new item. So number 2 access. Okay, the type, that is a continuous access. In some motion control project, we want to use the encoder running as a master access. So we can select this encoder access. That time, we only have this drive area. We only have the encoder area. So we can read the encoder and evolve to the motion control. But most of cases, we will select this continuous access. Okay, click OK. So by default, we can see now that is empty. So now let's go to the drive and click this NC drive. And now we can click this job list. For example, we are using the analog output controlling one DC motor. So in this case, we will select this drive, KL, this here. For example, we are using the EL4000. The EL4000, that is the analog card. So we can select this. So if we record for this EL4000, that is the analog output. So from this access to the drive area, we will select this. And once we select this, if we click this link to, so the system will pop up which channel we want to select, because we only have one analog card, and that analog card has 2 channels. So here we can select the channel 1, for example. Okay, this is our output, the drive area. And for the encoder feedback, we can select this encoder and add here link to. So we can click this job list, select the analog input card. For example, from this job list, we can select this encoder analog because we config the analog input card EL3000. Okay, we select this. So if we record, so add here, that is the EL3042, this analog current card. Okay, now we expand here from this analog input standard channel 1 and channel 2 here. Now it's showing nothing here. Okay, let's go back. Access to encoder. Make sure we're selecting this. And now we click this link to. So because we are using this analog card, it has 2 channels. For example, I select this number 1 channel. Click OK. And after we select this, if we scroll down, we will see here it shows some difference here. Because I used this channel 1, so we will see now this icon has been changed. We'll see this link to automatically link to the access to the variable. The variable comes from the system. Because the access, this access to help us to automatically config this. And this allows once this analog card read the data, so this data will transfer to the access. And comparing with the channel 2, I didn't configure anything for channel 2. So the channel 2 here that shows empty. But this channel 1 now is already automatically configured this tag. Same thing as this analog output card. So the output, analog output, so we can see. Because we configured the channel 1 as the drive of the access 2. So it has this variable here. But this channel, I configured nothing here. So that is empty. Also quickly review this terminal 4, EL7200. This positional values, everything here, it automatically connected to something here. Because this card running as a loop, it controls the servo motor and reads the resolver encoder. So it has everything connected here. Okay, so quickly review this access tool. So we configure the drive for the analog card output, configure the analog input to this encoder. So once we go back to this access tool here, so the system automatically connect to this. This is analog input card linked to I/O. System automatically connect this. And from this job list, let's review. So the access type that we can select is a standard mapping with the encoder and the drive. And according to your case, we can select the unit. Also, sometimes we could change here for the cycle time. The shorter time we set here, the better performance we could have. However, higher workload the controller will be. So this value need to be balanced between our performance and the processor workload. So if your system do not need the motion high performance, sometimes you could enlarge this value. For example, enlarge to 4 milliseconds or 8 milliseconds if you do not need that high performance. Okay. After we configure this page, we can go through the parameters. The parameters here, that's the area we can configure the maximum, minimum acceleration and velocity. And for the manual motion homing, we can configure something here. For example, the homing velocity and the manual velocity, the fast and slow speed. Some cases for the fast access stop, which kind of the stop signal type we can select, for example here. That is optional. And the fast acceleration and the deceleration, so we can set something here. For example, I will set this is a higher flow. We can select 2000, some cases, and the faster jerk. And this is a limit switch, monitoring. And here, this monitoring, if you are controlling one actual axis, especially if your motion load is heavy, sometimes you need to enlarge this lag value and enlarge this filter time. We can see this is a position lag monitoring. If you command and your feedback, if this lag larger this value, so our system will show the monitor fault. You will get a lot of fault because our load is heavy. That time we set something, but actual load and actual speed or position cannot reach that set point in a short time. It will show some faults there, so which is really annoying. Sometimes we can enlarge this, or some cases we can disable this. Also for this target positioning monitoring, so if we need a very accurate that positioning control, so probably we can leave this as a default or make it a narrow. If that positioning, we do not need that so accuracy, so we can set this larger. And other settings, basically we will leave this as a default, unless sometimes we want to change this velocity window to a shorter, or just a filter time for velocity window. So we could adjust this a little bit. It depends on what the high performance you need to do for your motion control. Okay, this is a quickly review. And let's go to the dynamic. So if you find your motion system for the acceleration and deceleration, we need to optimize a little bit. So you can adjust this, depends on your actual hardware behavior. For example here, if we drag this block to this direction, that makes the acceleration deceleration lower than before. So the system shows smooth, but shows slow. And if you want to adjust your system, shows very aggressive or very active, you could enlarge this. It depends on your mechanical system performance, also depends on the motion performance you want to reach. And other than this, online, this is a very common function. I will introduce this after. And once we connect the hardware and download the controller, before we use the program to control our access, the best way to pre-test the hardware and the mechanical system, that is using this. We could call this the motion commissioning panel. So we can use this directly control our access and test the encoder feedback. So without involving any program, so we can directly test our mechanical connection, test if the drive can run properly, and test the encoder can be read properly. This is a very handy tool. Since I don't have the hardware in my hand, but I can use the virtual access do this test. I can download this virtual access into my laptop and test this virtual access. That time we can see this online status and this online panel commissioning. I will show how can we use this in next video. Okay, and from this function we can set this extended start for the acceleration deceleration. Okay, this is the coupling and compensation. Basically we will leave this as a default. Okay, this is the access setting. Most of the cases we will set something at here. Okay, and then let's go to the drive. Sometimes if you need to optimize your drive, the parameter, so you could set something here. This is the drive. Also for the encoder, if we need to scaling or ratio our encoder value, we probably need to set something parameter here. For example, this encoder sign interpretation. So probably we can select this unsigned or signed, right? Also in some cases we need to set this scaling. That depends on the encoder and your mechanical relationship. And this is our actuator and the feedback. And other than this, for the control method, for the positioning control, we can select the positioning controller. For example, you could use the P, or use the PID, or use the PI for torque control. It depends on the actual application. most of the cases, we will select this P only for the positioning control. Basically, those parameters need to be tuned once you connect the actual load and connect everything together and run your machine. You need to optimize the performance. That time, you need to tune those parameters a little bit. Okay, this is a brief review for some important settings in Access. So in this video, we configure the drive and configure the encoder. Also, we review some settings under this Access. And once we configure this, we will click this Build Solution and download our project to the controller. And after this, basically the first things after the download, we will go to the Access, click this Online. So we will directly use this panel to test our Access and verify the encoder. In next video, I will use one virtual access and download this project to my computer, and I will use my computer running as the controller. And I will click this online and show how can we use this commissioning panel to test our access. Alright, see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.